Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in the Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the various methods for presenting the data in the subject of principles of data science. So data presentation, so before going to see that, so what is the data? So data is nothing but a set of values recorded on one or more observational units. So that may be either an object or person. So there are different types of data like qualitative and quantitative data, discrete and continuous data, primary and secondary data, nominal and ordinal data. So the data is going to be in different types. So like qualitative data and quantitative data. Again, it should be of the type, so discrete and continuous data, primary and secondary data, nominal and ordinal data. So data presentation. So what are the principles we have to be followed for presenting the data? So for that, the data should be arranged in such a way that it should be create an interest in reader, and the data should be made sufficiently concise without losing its important details, and the data should be presented in simple form, so enable the reader to form the quick impressions and to draw some conclusion, either it may be directly or indirectly. And it should also facilitate further statistical analysis. So then it should also define the problem and suggest a solution. It should also facilitate further statistical analysis, and it should also define the problem and suggest a solution. So what are the various methods of presenting the data? So for that, the first step is that statistical analysis, which should be able to present an easy way to understood. And there are two ways of data presentation. So first thing should be tabulation, and second thing should be charts and then diagram. So some of the methods are available. So normally you are going to present the data in the form of tabulation, or it may be in the form of charts and then diagram. So the first step in the statistical analysis is that it should be easy way. So very first thing, so whatever the data we're getting, that should be in the form of raw data. So this data is able to represent for presenting clear. So whether I can able to represent the form of a table, and the same thing I can also present in the form of charts, or that it may be a bar chart or pie chart, or I can also represent in the form of pie diagram. So these are the simple ways of presenting the data here. And next one, what are the rules we have to be follow for representing the data in tabular representation? So for that, so very first thing is that the table must be numbered, and so the brief and explanatory title must be given to each table, and the headings of columns and rows must be clear, sufficient, concise, and fully defined, and the data must be presented according to the size of importance, chronologically, alphabetically, or geographically. So if the data includes a rate or proportion, so mention the denominator. Then the table should not be too large here, and the figures needing comparison should be placed on as close as possible. So before going to present the data in the form of a table, so very first thing we have to follow some of the guidelines here. So the very first thing should be the table should be numbered, and the brief explanatory title should be given for the table, and the headings and columns so must be clear, concise, and sufficient and fully defined. So the data must be presented according to the size of importance, chronologically, alphabetically, and geographically. So if the data includes a rate or proportion, so mention the denominator, and the table should not be too large, and the figures needing comparison should be placed as close as possible. So the continuation of the principles, so what are the classes we created that should be fully defined and should not lead to any ambiguity, and the classes should be exhaustive, so that is should include all the given values, and the classes must be mutually exclusive and not overlapping, and the classes should be of equal width or class interval should be same, and the open-ended classes should be avoided as far as possible, and the number of classes should be neither too large or too small, and the formula for the number of classes should be the k is equal to 1 plus 3 log n, which should be a total frequency, right? So the classes must be fully defined, so it should not be lead to any ambiguity, and the classes should be exhaustive, that means that we should be include all the given values, and the classes should be mutually exclusive or non-overlapping, and the classes should be of equal width or class interval should be same, and the open-ended classes should be avoided as far as possible, and the number of classes should be neither too large or not too small, and the formula should be that, so normally for defining or calculating the number of formulas, so k is equal to 1 plus 3.3 log n, where n is the frequency here. So next one, the tabulation. When it comes to tabulation, so it should be a simple form or it may be complex, so depending on the number of measurements of a single set or multiple set of items. Simple table, so normally it looks like you should be going to have the rows and it should be columns. So the title of the table should be number of cases of various diseases in a hospital. Okay, so here what I'm going to say that is, so the tabulation should be either simple or complex, so depending upon the number of measurement of single set or multiple set of items. So the disease should be simple, so here I'm considered only the two cases. So column disease and then cases, and then what are the diseases identified from the different hospitals, so like Nair Hospital in 2009 and cases identified. And the friend comes to frequency distribution data with the qualitative data. So here what will happen is, so previous thing should be the simple table. So if I want to make this little bit, suppose the cases of malaria in adults and children in months of June and July. So here June I have to consider as well as July also I have to consider. So for that what I have to do, so I have to create June and July month, and the types of diseases in case of adult and children. So this should be a little bit complicated when compared to the previous. Similarly, the frequency distribution with the quantitative data. So for that, the fasting of glucose levels in diabetes at the time of diagnosis, I want to say. So for that, what I have to do is that I'm going to consider different fasting glucose levels. For I want to find out for in case of male and female, what should be the diabetes count and what should be the total count. So like this, I can able to represent the data here. So the frequency distribution table is that, so where the glucose level should be diagnosis with the quantitative data. So when it comes to chart and diagram, so here, so the previous thing should be representing the data in tabular format actually. So this is the another way of representing the data, that should be charts and diagrams. So it should be nothing but the graphical presentation of data which is going to be used to illustrate and then it should also present the data very clarity. So the tables should be essential for this, for the presentation of scientific data, and the diagrams also compulsory to summarize these tables in an easy, attractive and simple way. So the graphical presentations are going to be used to illustrate the clarity information, and the table should be the essential representation of scientific diagrams, and scientific data. So it should also be summarized to make the presentation should be very simple. So the diagram should be all the time, it should be simple one and easy to understand. It should also save a lot of words and so self-explanatory, and should also have a clear title indicating its content and fully labeled, and y-axis should usually is going to be used for the frequency. So the diagram should be simple, and it should also be easy to understand, and should also say a lot of words, self-explanatory, and should also have a clear title indicating its content, and should also fully labeled one, and the y-axis is usually used for the frequency here. So whatever the diagrams you are creating, that should be, while seeing this, it should be clearly understood. Depending on the contest, you have to choose what type of diagram you have to present it. So choosing is also important, and then illustration is also important. So if the content I'm going to represent in this form, suppose it in the form of bar diagram, so it should be something better when I'm going to represent it. So that and all you have to be taken out. So what for the particular kind of application, which chart or which diagram is the important one, you have to be chosen. And so it should also saves a lot of words. So by seeing the diagram itself, the viewers can be easily understood what should be. No need of explanation. And it should be have clear title indicating it's the content, what is that, and fully labeled one. So preferably you are going to choose this y-axis, vertically is for the frequency. There are various charts and diagrams like bar chart, histogram, frequency, polygon, and cumulative frequency curve, scatter diagram, line diagram, and pie diagram. Okay, so these are some of the various charts and diagrams we are having for presenting the data. So first thing is the bar diagram, so histogram, and frequency polygon, and cumulative frequency curve, scatter diagram, line diagram, and pie diagram. So the very first thing is that bar diagram. So this one is widely used diagram. So it should also going to prepare tool for comparing the categories of mutual exclusive discrete data, and the different categories are indicated on one axis, and the frequency of data in each category on another axis, and the length of the bar indicating that the magnitude of the frequency of the character should be compared, and spacing between the various bars should be equal to half of the width of the bar. And there are three types of bar diagrams like simple bar, multiple bar, and component bar. So the bar diagram is the widely used one, so which is used to prepare the tool for comparing the categories of mutually exclusive discrete data, and different categories are going to be indicated here. So one is for an x-axis, and the frequency tau is for the another axis, and the length of bar is indicating that the magnitude of the frequency of the character should be compared, and the spacing between the various bars should be equal to the half of the width of the bar. And there are three types of bar diagram: simple, component, and multiple bar diagram. So the simple bar looks like this, so it should also correlate between the two variables. And so in x-axis I'm going to take the number of diseases, type of diseases, and number of people that is going to suffer for this kind of disease, vax and flaxiparum and mixed malaria, like this. So there should be a simple bar diagram, so we're unable to represent it. Suppose for this, by seeing this, so the persons or viewers can easily understood, so that the 100 number of people are going to be suffered with vax disease, and 60 number of people is going to be suffer from falciparum, and maximum some 30 members is going to be suffer from the mixed malaria. So another type of bar chart should be multiple bar chart. So here each observation is going to have more than one value, and is going to be represented by group of bars. and the percentage of males and females in different countries, percentage of deaths from heart diseases in old age, and mode of delivery in different female age groups. Okay, so for this, what should be that is each observation should have more than one value. So it is going to be represented by group of bars, and then the percentage of males and females in different countries, and percentage of deaths from heart diseases in old and young age, and mode of delivery in different female and age groups. So this should be the representation of multiple bar diagrams. So so the same kind of application. So I would like to know how many number of males and how many number of females are going to be suffered with Vivax, falciparum, and mixed malaria. So for that, what I'm going to say that is, so but since it is going to be distinguishing two uh, characteristics from the same kind of disease, so I have to go for the multiple or compound diagram. So here by seeing this, I can this the blue is going to be indicates the male, and red is going to be indicates the female here. So what I'm going to say that is, so for the VVAX, so one or two number of people are going, males will be there, which is going to be suffered the VVAX, and then 57 number of people going to be suffered female. And falciparum is the another kind of representation. So we're able to use this male and female. So 62 number of male people are going to suffer the falciparum, and female should be the this. And mixed malaria. So we're able to where 29 number of male people are going to suffer mixed malaria, 90 number of people are going to suffer female. So the component bar chart, so there should be a subdivision of single bar to the indicates the composition of total divided into seconds according to the relative proportions. So for example, so the two communities are to be compared in their proportion of energy obtained from various foodstuffs, and each bar represents intake by one community, and height of the bar is 100, which is going to be divided horizontally into three A components of diet, and is going to be represented by different color or shape. So for this, the component diagram is going to be preferred one. So here what should be this? The height of the bar should be matches to the 100%, and the height of the bar should also where this height of the bar is going to be divided into different sections. So within the single bar itself, I am going to represent the percentage of energy obtained fats, and percentage of energy obtained protein, and percentage of energy obtained carbohydrate. So these are the things I can able to represent in a single bar. So here, so by seeing this, the pure community people were around so 80 percentage of energy obtained, and for within the pure community, some only the 10 percentage of energy obtained from protein, and 10 percentage of energy obtained from the carbohydrate. So similarly, if I'm going to take this the rich community, so 55 number of people are going to obtain fats, and 30 percentage of people have obtained energy protein, and 15%. So by seeing this, I can able to compare the rich community people how it would be, and pure community people how it will be. So like this, I can able to compare it. Next one is that histogram. So histogram is another kind of representation. So till now what I said should be bar chart here. That one should be of different types. Just now what I said should be simple bar, compound bar, and composite bar. Similarly, histogram so is the other kind of the thing. Uh, so it should be also similar to the bar chart. So with the difference that the rectangles or bars are going to be adherent, so without gaps. Okay, so normally here we can able to use this gaps here. So normally in bar chart we're going to represent the rectangle bar. So in histogram also we're going to represent it, but there should not be maintained any gaps in between them. That should be the difference between the bar chart and histogram. And it should also useful for presenting the class frequency table, and each bar represents a class and its heights represent the frequency, width represents the class interval. Right, so for that what I'm going to use, so it should be useful for representing the class frequency table, so it should be preferable only for the continuous data, and each bar represents a class and the height represents the frequency, when which width is going to represent the class interval. So histogram is under kind of the thing. uh, how it looks like this means, so it should be also looks like a bar diagram, but it should not, there should not be any gap in between these two bars. So that thing we called alt as a histogram here. Frequency polygon, so is the other kind of representing the data. So here actually this frequency polygon is going to be derived from the histogram. So by connecting the midpoints of the tops of the rectangle in the histogram, and the line connecting the centers of the histogram rectangles is called frequency polygon. And we can also draw polygon without rectangles, so that we can able to get the simpler form of the line graph. And a special kind of frequency polygon is that normal distribution curve. So frequency curve, so it should be derived from histogram. So by connecting the midpoints of the top of the rectangle's histogram, and the line connecting the centers of the histogram rectangles is called frequency polygon. And we can also draw the polygon without rectangles, so that we can able to get the simpler form of line graph. And special type of frequency polygon is the normal distribution curve. So how this frequency polygon is going to be obtained? So for this, so the frequency polygon is going to be obtained from the histogram itself. So once we get the constructed this histogram, so after connecting the midpoints of each and every rectangle, right? If I'm going to join with a line, so that should be called as the frequency polygon. So here, so initially it should be have like this. So normally this frequency polygon is going to be constructed by considering the class intervals only. So this is the histogram initially I constructed based on the class interval. This should be the class interval 1 to 129, and this should be the class interval 130 to 139, 140 to 149, 152. So this histogram is going to be constructed by considering the class intervals. So once that one is done, so what I'm going to do is I'm going to joining the midpoints of all this, right? So once I constructed this histogram, after removing after this, so the curve what I'm going to obtain is should be the frequency polygon. So the frequency polygon is going to be constructed after constructing the histogram only. And next one is that the cumulative frequency diagram or OGIL. So here the frequency of the data in each category is going to represent the sum of the data from the category and the preceding categories. So, and the cumulative frequencies are going to be plotted opposite the group limits of the variable, and these points are going to be joined by smooth freehand curve to get a cumulative frequency diagram or OQ. So here what I'm going to say that is, so the frequency of the data in each category represents the sum of the data from the category and the preceding categories. So the cumulative frequencies are going to be plotted opposite to that of group limits of the variable. And these points are going to be joined by the smooth freehand curve to get the cumulative frequency diagram or OQ. So this should be the presentation of OQ here. So normally this one is going to be constructed after OQ. So that one should be frequency curves. So how the curve should be obtained here is, so similarly in the same fashion. So normally after constructing the histogram, so what I'm going to do, so if I'm going to join the midpoint with a smooth freehand curve, so the curve what I'm going to obtain, that should be the frequency curve here. So the shaded area is going to be OQ, right? So that is the concept of OQ here. And next one what I'm going to have is scatter or dot diagram. So this is also called as a correlation diagram, which is going to be useful to represent the relationship between two numeric measurements, and each observation is going to be represented by a point corresponding to its value on each axis. And so in negative correlation, so the points will be in two directions. So it may be in upward direction or it may be in downward direction. So the downward direction is meaning that, so the relation between the two studied experiment is controversial. It means if one measure increases and the other decreases. When it comes to the positive correlation, so the points will be scattered in upward direction. That means if one measure is going to be increased, the other is also going to be increased. So that should be the correlation. So the correlation diagram is the thing which is going to show the relationship between two numeric measurements. So each observation is going to be measured by a point corresponding its value on each axis. So in negative correlation means the points will be scattered downward direction. So meaning that, so whatever the correlation measure is there now, so if one increases, the other also decreases. In positive correlation, so what will happen? So all the points should be scattered in upward direction. So that means one increases, automatically other will also increase. So this is the representation of scatter or dot diagram. So here is the example. So malaria cases, how it will be. So how many number in the month of month I want to represent it. So through the scatter plot. So here it should be 50, and the date I'm going to represent it should be May 30, and it should be around 95, which in June 89, and in July 2000, July 304 cases are going to be recorded in July month, and 450 number of cases are going to be recorded in August month. So this and all will be called as representing the scatter or dot. And another thing what I'm going to present is that, so relationship between the two numeric variables. So if all the points are going to be joined by a line or by a smooth curve or broken line, so that should be called as the line diagram here. So once you identify the values in the diagram, so if all the lines are going to be joined by line, so that should be the example of line diagram here. So let it be in 39, so 1, 39 is there, so 2, 2 and 4. So once the values are identified, so I join with a line or dotted line or smooth curve, so that should be called as the line diagram. So normally in most of the applications like cricket matches, so how many number of scores, what should be the line graph of India, and then what should be the line graph of Australia, like this I can able to show. So this should be the live examples of this line diagram. So the line diagram is going to show the relationship between the two numerical variables. So but the points are joined through a line, so that should be either broken line that I can able to use, or I can able to join with a smooth curve. So next, another way of representing the data is that pie diagram. So here is also another way of representing the data. So it consists of a circle, so whose areas represents the total frequency, and then which is going to be divided into segments, and each segment represents a proportional composition of the total frequency. So the pie diagram means, so essentially you have to construct it this, and based on the value, so let it be some x variable, it should be 30 and percent, and b variable should be 25%, and c variable is under 25%, and D should be 20%. So for that, what I'm going to use, so for A, I'm representing 30%. So angle should be 30, and this should be under 25, and this is under 25. So let it be 30 this, and 25, 25, and this should be 20. And this is for A, and this is B, and this is C, and this is D. So here the power diagram means where the area of the circle is going to be divided into different segments, what we call these parts, and each segment is going to be represents a proportional composition of curve. Let's see this here. So for that, 53% of people are going to be suffered with wax by seeing this power diagram, and 32% and 15%. So like this, I can able to represent the data in the form of bar diagram. So here mainly this percentage and values are going to be represented through either a bar diagram or scatter plot. Okay. So if I'm going to represent the percentage, then I have to go for the bar diagram. Okay. So these are the various types of representing the data we are having. So very first thing is that, so eventually you have to be follow some of those principles of presenting the data. So the principle should be the data should be arranged in such a way that it should be able to create some interest in reader, and all the time you have to be concisely present the data. You should also facilitate statistical analysis, and you should be able to define the problem and suggest a solution. There are different methods of presenting the data like tabulation and the charts and diagrams. So tabulation means where you can able to represent the form of table, and charts and diagrams should be in the form of diagrams. So here, before going to represent the data in the form of a table, you have to follow some of the rules and guidelines. Like the table must be numbered, and self-explanatory title must be given, and headings and columns should be created some reader, and the table should not be too large, and it should also, and all the data should be presented according to the size of chronological, alphabetical, and then geographical. So the classes should be defined and should be exhaustive. And so for finding the number of classes of an application, so this is the equation here. So 3 plus 3.22 log n, and simple tabulation looks like this, and frequency distribution table with the qualitative data will be looks like this, and for the quantitative it should be like this. And this is another way of representing the data here. So all the time, whatever the diagram we are considering, that should be simple, easy to understand, self-explanatory, fully labeled, and should also save lot of words. So there are different types of charts and diagrams are available. So bar chart, histogram, frequency polygon, and cumulative frequency curve, scatter diagram, line diagram, and pie diagram. So the bar diagram is the very widely used diagram. So mainly used for the discrete data here, and different types of diagrams are available like simple, compound, and component. Simple bar looks like this, where you can able to represent it, and so multiple bar means where for the single variable I can able to show different two characteristics. that should be multiple bar. And the component bar means where the rectangle is going to be divided equal to the 100 percentage. So we should also, I can able to represent the bar diagram. And the each segment where they divided the rectangle in different portions. So histogram. So the only difference between the histogram bar chart is that they should not maintain any gaps between the rectangle, then it should be histogram. If it is gaps is there, then it should be bar diagram. So how the histogram is going to be constructed like this. And frequency polygon is the thing where it should be derived from the histogram by connecting the midpoints of the tops of the rectangles. And the line connecting the centers of histogram called frequency polygon. So frequency polygon looks like this. Here they should be constructed after constructing the histogram. And cumulative frequency diagram, so they should be called as OQ. And how this one is, so after constructing the histogram, we have to join all the midpoints of the histogram rectangle. So what I obtain, we should the smooth curve, we should be the OQ. And another way of representing the data is that scatter plot or dot diagram. So it should be able to show the relationship between two numeric constants, and that thing is going to be represented through a point here, that one called as a correlation diagram. So in negative correlations, the point must be scattered downward direction, and where one thing is going to be increased, the other is going to be decreased in case of negative correlation. When it comes to positive correlation, the point must be scattered in upward direction. So this is the view of scatter diagram. And line diagram is another kind of representing the data, which should also show the relationship between the two variables. So whether it may be represented in the form of broken line or smooth curve. So the pie diagram, so it is a consists of a circle which is going to be divided into different segments. So each segment represents compositional total frequency. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.